Okay, you can hear me. Perfect. Thank you. You can hear me on Discord. I'm not sure if everything works on YouTube. So if someone is watching on YouTube, then let me know in chat if everything is working okay. Perfect. YouTube is also okay. So we still have like 4 minutes to, collect some questions and try everything. And then the streaming will be like 1 hour. Hi, Peter. Okay, hi everyone. So there are no questions. Perfect. I will have to find out what I'm going to talk about. So Max is asking, what is the topic? Electronics. So anything related to PCB layout, PCB manufacturing, schematic maybe. I'm very happy. Sami, you like the videos? Because sometimes, I'm a little bit confused what kind of videos I should be actually doing, because when I do the interview videos, some of them, they don't really get so much views, but I really enjoy making them, especially on different kind of topics. So I hope also other people like it. Okay, so your names are so difficult to say, so I'm not going to say some of the names. So the question, do you have knowledge in high voltage PCB design? I don't do high voltage PCB designs. Can we get some insight about USB Type-C? I've done video about USB Type-C, so I'm going to find it on my YouTube. I'm going to open my YouTube and so if someone would like to watch the video about USB-C, it was this one. And I created this video because I also wanted to move from USB 2.0 to USB-C, and there is actually quite a lot to learn about USB-C. It's quite different. And there is a lot of information in this video. So if someone is interested to start designing USB-C, then have a look on this one. There are more questions on YouTube actually than on Discord. So on Discord, I'm Pranav. Hi Pranav. I'm in the process of designing a carrier board I'm looking for guidance. Could you share some tips as best practices for creating? I have no idea what is this. I'm going to search for it. Xilinx system on module. I don't have much experience with Xilinx. I only done like maybe 2 or 3 designs running Xilinx. So yeah, I don't really have many tips about Xilinx, but maybe there is someone else who has some tips. And don't forget, if you would like to speak, then let me know. I don't know, do I need to click here? and I can enable the voice. Shorter videos are better, Remy. Mm, this topic about the length of the videos, there is a quite long thread under, I think under the video what I did with Eric. In comments, people are saying longer videos are better, shorter videos are better. So I'm going to a little bit answer why interviews videos are longer, and it's because, you know, I could theoretically like pick up only the most essential information from the interview videos and then make my own video, but that could be kind of, I think that's not fair for the people who are happy to share the knowledge. So I don't want to make this kind of content. Usually it works the way that people agree to make interview videos because it gives them some kind of visibility. I help them with, you know, maybe bring some people to their website or something like this. And that's why they spend their time preparing for the video. Because when I do interview videos, maybe you notice very often they have to prepare. So they create some kind of presentation, they prepare some examples, and it's a lot of work. So I don't like to like take content from these interview videos and then remaking my own shorter videos. And also second reason why, there are actually more reasons. One reason is, for example, for me it's much faster to post like whole video. There is still quite work to reduce some of the cut out some of the things from the videos, but it's still much easier for me to publish these videos. So it means if it's easier for me, it means I can publish every week. If it's more difficult for me, then I can't really publish so often. And also one other reason why I like to keep them longer is because, as I said many times, short videos can give you answer to your specific question, but they will not make you to understand why. And you know, for a very long time I have been designing boards based on rules, so based on, you know, do it this way. But I can tell you it is much better if you design boards the way that you understand actually what is happening. So that's the goal with the longest videos, with the longer videos. And Peter is saying Eric's Bogatin videos can't be long enough. Actually, I agreed with Eric on making another video, maybe in December. So I look forward to this recording. Okay, what's happening on Discord and on YouTube? Samip, I was wondering if you could have any information regarding a robust AC/DC power supply design. If I find someone, or if you have tips for people who are working with these higher voltages or you know, doing this kind of power supplies, let me know. You can always send me message on LinkedIn, or when I post a new video on LinkedIn, just put their names of these people and I will try to contact them and we can make videos on all the kind of different topics. I'm very interested to, you know, make video about these kind of topics, but as myself, I only have, most of my knowledge is about the digital design, processor boards, microcontrollers, and, you know, this kind of things. So I can't really talk about many other topics, only through the people who I interview. Okay. I'm designing Class D audio amplifier. I've been looking into PCB layout, up notes. One of them said that you have to route the analog section ground using star method and the digital power section using a solid ground. Any ideas why? Again, analog, it's not my area, but when I use analog on my digital boards, then now I always use solid ground. I just place it somewhere into corner of my PCB. And the reason is because once we had EMC problems when I separated this analog ground and the digital ground, so I don't do it anymore. It may be different for amplifiers because there will be higher currents, but I don't know. I would like to, again, this could be a very good topic for a YouTube video. So if you know someone who is designing audio amplifiers and he or she is really good, then we could make YouTube video and talk about tips and tricks and how to do this kind of designs. So give me some names, especially on LinkedIn, or you can post them somewhere here. Now I should find a question what I can actually answer. Okay, so I'm looking at the questions on YouTube because there are more questions. Decoupling capacitors. Is it bad to use two decoupling capacitors, a 10 microfarad and 100 nanofarad nearby the IC power pin? We were talking about this topic with Eric Bogatin. So if you have a look on some of the older videos, which one was it? This one. It will help you to understand a little bit better what is about the values. And I think this is the long one, yeah. So this will answer your question, what decoupling capacitor value to use and where to place them. But basically, the simple answer or very quick answer is that what you may want to use are like 1 microfarad capacitors, and it's not really necessary to use 100 nanofarad capacitors. But it's not like something wrong. You can still use 100 nanofarad capacitors and then use one bigger one. It depends on price, how sensitive your board is. I still use 100 nanofarad capacitors almost everywhere because I think 1 microfarad sometimes may be a little bit more expensive. I'm thinking if I should move the YouTube chat somehow here so you can see it. Oh yeah, here is. Okay, thank you very much, Charles, about the tip for copy. I'm going to open it. And it will be in the stream, so I will don't forget. Oops. Okay. Do you have some information or comparison of 2-layer PCB and 4-layer? I can't recall, but in one of your YouTube videos, you have discussed how bad 2-layer boards are. Actually, today I was talking to someone who wanted to make some measurements on 28 pins board, and I suggested that maybe we could come up with better examples, so which we could compare EMC results, and this could be really cool, like maybe comparing 2-layer and 4-layer PCBs. And I keep saying 2-layer are really bad because most of my bad experience with unreliable boards was with 2-layer PCBs. And it was when I was starting with hardware design, and it was very long time ago, like 2003 or something like this, 2000. And it means multi-layer PCBs were quite expensive. So my boss, he was always like, we need the cheapest boards as possible. So we designed almost everything on 2-layer PCBs, and we had a lot of crosstalks. And at the time, I didn't know exactly why my boards are, freezing and crashing, and they are not reliable. But now I'm pretty sure it was because they were 2-layer boards with many traces on top of each other and no solid ground planes, anything. So we definitely, this could be a very interesting topic to make real EMC measurements between two basically same boards, but 2-layer. One would be 2-layer and one would be 4-layer. Good idea. I have to remember this. But right now I don't have any examples like this to show, just my experience. Okay. At what signal frequencies does it make sense to match the line impedance on the PCB? Actually, I try to do it for everything. Because again, we were talking about this many times, and the problem is not the frequency. Problem is the rising and falling edge. And today's ICs, they actually can be very fast. Very fast, it means they can switch the levels very fast. And this is what can actually cause the problems. And if your impedance matching is good, then it will minimize the reflections. So the signal quality will be better, even if it's faster. So it's not like a question of frequencies, because if you design it properly, then also, whole PCB will be quieter. If you don't have crosstalk, then I don't know, you will not get like random interrupts. You may pass EMC easier. It can be easier to pass EMC. So these are the reasons why matching the impedance is good for everything. It's not a big deal because or it can be a big deal if you are designing 2-layer PCB, because then you can't really do it. But if you are designing 4-layer PCB, then just double check with your PCB manufacturer what is the track width for 50 ohms, and just route all the, or adjust the track width of all the digital traces to 50 ohms. Do you have any guide about STM32 boards? How are they different from ESP32? So there was time when I really wanted to make tutorials based on STM32, but there was this, big problem to get STM32, and I then discovered ESP32, and I started using it. So I really didn't go into STM32. I have a board somewhere here which I bought, and I never connected it to computer, because once I started playing with the ESP32, and it has Wi-Fi, it has Bluetooth, there are many examples on internet. You can use Arduino, environment to program it. I never really had need to go to STM32. So once it is popular again, I'm pretty sure I would like to make a tutorial about this, but I have to wait and and see if people will go back to STM32. Maybe it's only my feeling, I don't know, maybe I'm wrong, but I think many people just went away from STM32 because it was not available. I have PCB for 160 amps. When calculated, I need really thick layers. I'm thinking to solder copper plate and use simple 4-layer PCB. What do you think? I don't know, is it like continuous 160 amps? If yes, there are I'm sure there are options, so you can actually order a PCB with very thick, I'm not sure if copper, but maybe they use like aluminum layer or something. Maybe that could be something what you could use. When I'm designing like processor boards, and there is because some of the processor they are up to, I don't know, 150 amps, but this is just peak. Then often I just use multiple layers for this, and it's okay. Maybe that could be also a solution, but I see I see you would like to use 4 layers, so I don't know. Actually, I don't know if they can do 4-layer PCB with so thick top and bottom layer. I'm thinking the JLC PCB, maybe they are doing this kind of. I don't remember. Do they have like aluminum? Oops. Well, this is only 1 layer. And 1 OZ. Okay. That would not help. And what was the maximum thickness? I think standard what they have is only up to 2 OZ. Maybe I think someone else is doing this. Maybe someone who is watching this live stream can help you. A suggestion, can you make video on DDR, different types of routing involved, when to use different kind of routing? I'm thinking if I created something like this. I think some time ago I created, it's not exactly this, but there was a video where I explained how to set up rules for flyby and T-branch. So maybe that's where I explained also a little bit about why we would like to use them and when. But it was a long time ago. I don't know which one was it. Hi, do you plan, Gary? Hi, do you plan to do a KiCad based board with DDR memory similar to OpenRX? Not right now. Right now, I use the Easy EDA a lot, and also I have a Altium tutorial what I'm working on, but I have not finished it yet. I would like to leave KiCad to other people, like Phil, for example. And I will go back to KiCad once they make I think I mentioned this a couple of times. Once they make some improvements, especially in libraries, because that's something what I really miss in KiCad. You know, they should have something like what Easy EDA has, like you just pick up the components and you don't have to create them, you don't have to pair the symbols and footprints. So once KiCad has something like this, I'm going there. Sergey, the material datasheet gives different decay, DF or frequencies. What value should I use? Actually, this is one of the videos what is on my to-do list. So I talked to someone to help me to create a video on this topic, like compare different materials and how it influences the signals. So it will be coming. There are actually much more questions on YouTube than on Discord. We created Discord because, as you know, YouTube has full control over our subscribers, and you know how it shows the YouTube videos and everything, and notifications to people who watch my channel. So that's why we created Discord to be able to go like around this algorithm, because sometimes it's like super sad when I see I have 130,000 subscribers and I publish a video and YouTube will show it, I don't know, to 500 or 1,000 people, and then if YouTube thinks they don't like it, then it just will stop pushing this video. So it's kind of useless actually have 130,000 subscribers if YouTube doesn't want to show them everything what I publish. So I hope when people go to Discord and when I publish there something, for example, there is a new video, then maybe more people will know about it. But maybe I'm wrong, I don't know. Pranav is asking if I have the experience designing carrier boards for other devices. Yeah, I design a couple of base boards or carrier boards for different kind of modules. If yes, could you share your insights or lesson learned or any valuable tips for your... There is nothing special about designing carrier boards. It's maybe even easier than designing whole board, because the most critical part, the processor, memories, and everything is on the module, which you don't need to do anything with. And the baseboard, very often this baseboard is they have available schematic and PCB layout. You can just remove what you don't need, and you know it means there is very high chance that when you design baseboard, it will actually work. So it's good because you say, I'm new to this, so that's right way to do it. You can start with designing baseboards because it's easier. And as I said, there is nothing like super special about this. If you are not sure, have a look on reference design. I know in number of videos in these recent years, I said, and we were talking about reference designs and how some of them are not very good. Yeah, but there is not much what I can do about this, but at least you know these boards work. This is interesting. Do you think learning Chinese language is beneficial for importing electronics and starting business, or does online platforms offer same advantage? I don't know, but I was thinking maybe to try to learn some Chinese. So then I will let you know. Uh, Especially after my trip to JLC PCB, it was interesting, and if I don't know if it will have a real benefit, but it was it was difficult to communicate even in English. I know some of them, they know their English is good, but many times English is not is kind of average. And if you ask like two technical questions, you will not get like proper answers. And I was talking about this also with some other people, uh, and they had very similar experience, like visiting factories in China and trying to ask questions. It was difficult for them to get proper answers because of the language barrier. So maybe if you would like to work with Chinese companies, you may want to actually learn Chinese language, because even if they can speak English, if you go into more details, then there may be misunderstanding. Uh, Hi Robert, any possibility that you will bring magnetics design course? I I don't actually know anyone who can do this kind of topics. Again, this is something what I was thinking about to make an interview video uh, and simulate this kind of behavior, but I don't know who is actually doing this. And as I mentioned, there is another question about AC/DC. Again, as I mentioned, if someone knows people who work in these AC/DC converters, high current design, high voltage designs, let me know. Just uh, send me email or leave message on LinkedIn, and I will try to contact these people and make videos about this. Okay, Max. My boss is against calculating critical length of the track because he thinks that, for example, for 20 megahertz speed, the wavelength is about 3 meters, which is quite much more than any PCBs produce. In other words, when we make PCBs bigger than 3 meters, we should carry about critical length. I think maybe when you find some design guides, I don't exactly remember like ATA frequency. But I think there are some recommendations like length matching or doing these kind of things like within 3 centimeters. But I don't know, was it about length matching? Critical length. What does it mean, critical length? You mean like when it starts being messy? Oh, okay, yeah, that's what I mean. Okay. But again, this is also something with the rising and falling edge. I've done a video on something similar. It was I think it was this one. So you can have a look. And maybe this can help a little bit. it's not exactly answer on your question, but the when I was playing with this, I made some of the simulations shorter, some of them longer, and there were differences in the results. I hope it is in the video. And again, it was about the edge. It was not about frequency. Oh, you cannot see it because it's on YouTube. Okay. I will in the link address. This one. Hi Robert, is it possible to decide number of layers on StackUp without doing fan out? Oh yeah, sure. Just for example, if there is memory, you can very easily, very often say you need 4 layers to fan out memories. And I think that's what usually specifies number of layers, how many you really need. If there is no memory, then I don't know if you can somehow specify it. I think probably you should be able to also do it based on how deep you need to go with the, it means how many, rows and columns the biggest BGA has, and how deep you have to go and fan out the pins. But again, this would depend if you have to fan out all the pins, for example, or only some of them, because usually first row you can fan out on maybe top layer, second row you can fan out on top layer, but then deeper and deeper you go, you need to go on different and different layers. And if there is no space, if you have to fan out every single pin, then it's kind of quite easy to calculate actually how many minimum layers you will need. Without actually doing the layout itself. Okay, what else? I need to scroll up a little bit. I see there are electronic word. There are many comments from electronic word. Can you design MIPI DSI based something? I don't know what I should answer. I can, but it's just one of the interfaces. Okay. I see unusual join activity detected on Federal community. I have no idea what is this. Oh, maybe people from YouTube are joining. I don't know. I'm checking these messages on Discord. Custom transformers. I don't know. This is not my area. How to be able to tell if I'm over-engineering a two-layer PCB design for signal integrity? You are probably over-engineering PCB design if it's on two-layer PCB, because if you really need good signal integrity, then you would be using 4-layer PCB. And you would not be trying to do it on 2-layer PCB, because on 2-layer PCB, problem with 2-layer PCB, even if you have solid ground on second layer, the PCB is quite thick, and for example, just making 50 ohm tracks, you would have to make them, I think, very wide, so it's not kind of realistic to do proper high-speed routing on 2-layer. At least I have never tried this. Maybe some people do it, but because 4-layer PCBs are very cheap these days, I can have a look actually. You are not watching YouTube probably, but I'm going to check JLC PCB and compare price between 2-layer and 4-layer PCB. Okay, 2 layers, $2, and 4-layer, $7 for small quantity, same size. I know for mass production, it's still very small difference. For mass production, like even very complex PCBs, 10, 12 layers, they are not expensive unless they are large. If they are small, if your PCB is small, then you don't need to worry about PCB price based on number of layers. Should we reduce the inrush current for both capacitors? I was never really like investigating any problems with this, so I don't really know much. I don't have any like special insight to this topic. Did you ever do USB PD 48 volts? Not yet, but I hope I will. Please help me explain tuning layout in PCB design RAM DDR4. I'm thinking. I think I have not done. I have not done specific video about tuning DDR4 memories, but I have done some videos about DDR4 simulation and also DDR4 measurement, and you can get a lot of information from there. It's not like very different from DDR3 memories. There are little bit different signals, but DDR3, 4, 5, it's all basically kind of same. So same way as you do tuning for DDR3, you would do it for DDR4. I don't know exactly what you would like me to tell you how to do it. I'm thinking. I don't think there is something super special about it. Unless you have never done memory tuning, then yeah, there are some tips and tricks how to do it. For example, very often when I do these kind of things, you create some kind of envelope. You need to find out which signal is going to be the longest one, and then you try to do it this way. Also, you may want to use pin swapping to optimize the connections. It will help you with length tuning, but it's like hard to explain it like this. I talk about this a lot about in one of my courses actually. Okay, what are the other questions on YouTube? And thank you very much actually for coming to this live stream, because when I was testing like 1 hour before a live stream, there was no one. Then like 30 minutes before a live stream, there was no one. 15 minutes before a live stream, there were like, I think 4 people on YouTube. And I was like, oh, maybe there will be no questions. And then I will have to talk to myself for 1 hour. So thank you very much for coming. I saw your video about JLC PCB about 2 or 3 years ago. What do you think about it now for mass production? Mind-blowing. So basically what happened, if you remember my video, one of my very first videos about JLC PCB is the one where I made the mistake in button connection. I always remember it. It was very embarrassing. But basically, it was a couple of years ago, and JLC PCB, they have changed a lot. So a couple of years ago, I created this video, which was called "Is Chip Assembly Good?" or something like this. Chip assembly. Sorry, not here. Here. If you are on Discord, you don't see it, but I'm searching for specific video, this one. So this is the one embarrassing where I made mistake in button connection. And it was 2 years ago. And they actually did, there were some problems with soldering and also pin 1 rotation. But since then, they improved a lot. I have manufactured a number of boards since then in JLC PCB, and I was very happy with what they did. And that's one of the reasons why I asked them if I could go and visit them. And when they said, yes, I can go and, create the video, I was super happy. And when I saw how big the factory is and how automated everything is, it was, I'm telling you, mind-blowing. I'm still working on the video from the PCB production. I just send it to review. So, I ask them to tell me if there is something what they don't want to have in the video, maybe blue or something, or this kind of stuff. And once I will get it back, I still need a little bit of time to finish it, but it's around 1 hour. It's like full story of a PCB, like from start to finish. And there is also assembly and 3D printing. So it's like super cool. So once you will see it, then you will understand how big they are. When I was talking to them, many PCB manufacturers in China, they don't manufacture the PCBs by themselves, or maybe they have some technologies, but not for everything. And that's why JLC PCB, they can actually be very competitive in price, because they actually have all these technologies. So they can really manufacture it so cheaply because they have all these machines. So I'm going to keep using them. I just would like to tell you, they don't pay me anything. They wanted to pay for my visit. They wanted to pay me for recording the video, but I told them I'm going to buy the flight tickets for my own money. They helped me going around and staying in China. So it was kind of like we shared the expenses, and they didn't pay me for anything. They still don't pay me for advertisement, for anything. I just do it because I use them, and I like how they actually make the PCBs. Sanji. Hi Robert, any tips on what is a good project to test a designer skills like SBC, or is that something way too complex, expensive for this type of proof of skill? For what reason you would like to test the skills? And also, I'm thinking maybe it's not like super important. For example, when I'm hiring people, you need to look not really for you need to look for people with a really good attitude, like they would like to learn something new, they are able to work by themselves, they will figure out the problems and solutions. I think that's what is really important for people. It's good to have some skills, it's good to have some experience, but very often when you are hiring someone, they may have this experience and skills in different areas, and very often you will not find specific person for specific job. So I don't know if it's like really necessary to test or use some kind of test to test designer skills. I remember once I went on an interview when I was looking for a job, and they started asking me all the questions about amplifiers, and as I explained at the beginning of this stream, like I'm not really good in amplifiers. If I need something, I just Google it, yeah. And I completely failed the interview. But I don't think I'm so bad. And if I need what they ask me, I just would find it on the internet. So I think much better would be if you have a look what kind of projects these people were working on, and if they were working on these projects by themselves or if in the company. I think that's good enough to get some kind of feeling about the experience of the design engineer. Peter is asking if I have some practical experience with using silent switches. No. Okay. What else? Why are Raspberry Pi and Arduino so popular in the world? Because of software. I'm pretty sure it's because of software. Arduino is so popular because they created the Arduino environment, which made it super easy to start with the board. I'm pretty sure you tried STM32 or some other chips. If you try to install the IDE and just writing and running hello world in this, IDEs for if these IDEs for from chip manufacturers, if they would be better, then it would be good. But because they are not good, I think that's where Arduino won. Starting with Arduino is super simple. Writing hello world is super simple. Sending your data from Arduino to your PC, super simple. If you would like to do this on chip level in all these, special softwares for the chips, you may spend hours and it may still not work properly. And Raspberry Pi, it's same, or Raspberry Pi. I think it's the same because they have good software support. It is a little bit higher level than Arduino on Linux base, and it's a cheap board where Linux is running. So many software engineers, they could actually use this board to run their projects. So software, definitely software. Using Altium, which tool will be best to perform SI simulations? Did they improve their tool for SI? I think they're actually, I don't know if it's official, and I don't remember if I can talk about some of this stuff, but I think they're partnering with someone who is going to help them with simulations. So I don't know if it's officially out or not. So I don't want to say exactly who, but if it's not out, then it's coming. Because it's, that's the weakest point of Altium. Right now, simulation is the weakest point of Altium. If they are able to cover simulations, then they have basically everything. What else? So, Sanji, what would be a good way to reduce board area? Making a board sandwich or going to the smallest components and super dense? Yeah, I think multi-board design is one of the ways how to reduce board area if you can make it bigger in volume, if you mean like size. Do you calculate how much time it will take when you start another project? You can guess. I have done there is a video. I'm going to find it. I think it's called How Long It Takes. Yeah, you can have a look here. There are a couple of projects, but basically once there is, for example, memory interface, it's going to take, I don't know, hundreds of hours. If there is no memory interface, it can be 10, 50. Depends what everything you would like to include. If only schematic, PCB, or also software. So, and once you already done a project, then your next projects may be quite similar because usually companies are working on similar kind of boards. You will be able to predict it more accurately. But from my experience, the kind of boards what I was designing, so processor boards, usually it was 1 year for development from like start up to like production. And it's because it may take like 3 or 4 months to have prototype, but then all the testing, software, and then documentation, manual, and everything, and also maybe second revision to fix possible issues, 1 year. So Electronic Addict is asking, based on your experience, can you please share about pre-preg material selection for your board? I'm working on a video about this. I asked a number of people if they could help me to make this kind of video. And it's very hard to find someone who can do that. But I hope it will be possible and it's coming soon, including simulations and all these other stuff around it. So I don't know exactly yet, but I'm also curious. For my projects, usually when the boards are small, I'm not very picky about the materials because I don't go like to the highest speeds and I don't go to super long boards or super large boards. So what are the most demanding electronic skills which can land me a good job? That's interesting question. I think if I remember from my experience, if I remember, I've got the job because I had experience with the chips what the company was using. So basically, if you have some kind of company in mind where you would like to go or what kind of boards you would like to design, it can be helpful if you already have experience with this, and then you have high chance to get the job. So it doesn't have to be like maybe specific skill. I think this is probably strongest advantage if you already work on what they need. Again, similar questions from Sniper. What material would you use for PCI Express Generation 3? We will be comparing this. Again, I think it would depend how large board and this kind of stuff. But I'm also curious to see the simulations and I'm curious to see how long the tracks can be for different materials. Zola, if you have to work on something that you are not familiar with, where would you look first for guidance? Books, internet, or something else? Reference designs and design guides. That's how I learned. So you find reference design for the processor or for the kind of board you would like to design, and then find the design guide for this specific processor, and they will explain everything. Again, we are back in the question how good these reference designs and design guides are. If you choose, or if you have option to choose, I don't know, Intel or AMD, they will have good design guides. If it's going to be someone not well known, then yeah, I don't know how good the design guide will be. So maybe that's important also to point out. If you can, then choose a chip from a good chip manufacturer, so they will also have good design guides. Not always, as in some of my videos, some people pointed out that even big companies, they may not have the best reference designs, but there is, not much like other sources. Internet is tricky because you don't know exactly how much you can trust the source. Books, I don't have many books on this, and I find it more difficult to learn from books. I don't know why. For me, design guides and reference designs are the best source. Shall I click here? No. Maybe Altium 24. There is an see. Okay, you found it. ANSYS. Yeah, I think it was ANSYS. There, that's it. How to reverse engineering chips works. Working on the video, coming maybe next week. I'm just waiting for thumbnail. It's so cool video. I did it with John. I think his name is John. and he will talk about how to remove the packaging and how to probe the silicon. So you will see in the video he will be putting probes on the silicon and using laser drilling into the inner layers. I was like, wow, how someone can do this. So look for this video, reverse engineering chips work. The main motive is not like only like bad reverse engineering, but he will explain why he's doing this. But it's very often for like older machines, older designs. If there is no documentation, if documentation was lost, something has to be fixed. So that's why he's doing this. What Ethernet switch IC manufacturers do have good reference designs? I don't know. I don't know. Usually I use the Ethernet switch. I don't know. So when I was doing this kind of designs, I usually bought number of devices. I opened them, had a look what they use. That's how I choose the chip for my design. Okay, so another question from Zola. What elements of circuit and hardware design should young engineer learn first? I was actually asked to go back to the university where I studied and do presentation for the students. And I was exactly thinking like what to talk about. And I'm thinking about the topic like what something like I'm going to I would find it. It was something like what I really wish I knew at university is important for me to learn before actually going and starting designing the PCBs. So I think one of the most important things what I will highlight and point out is impedance. So at university we learned about impedance, but I had no idea actually how impedance is important in, for example, PCB design until I started making all these interview videos and finding out how important it is for power delivery, how important it is, for signal quality. But at university, they will not explain this. They will just tell you, this is how you calculate it. This is your exam. Here are these, problems. So just do it so you can pass these exams. So one of the things, what elements of circuit and hardware design should young engineer learn first? Impedances. Learn a lot about impedances. Because for a very long time, I really didn't think about impedance. I was thinking only about like resistance, and that's like bad thinking, okay? Impedance is something more accurate. What else could be there? Impedance, and what else I mentioned? Return currents. Return currents is very important, so you can imagine better how signals will travel in your PCB. That's not maybe like circuit design, because I think PCB layout is actually, I think, harder than circuit design. Circuit design, you can, if you make mistake, you can just fix it. You redraw the schematic, you put a new component or something like this. But if there is problem in PCB and if you don't understand what the problem is, then it's very hard to fix it. Can you make the video on reverse computing? I don't know what reverse computing is. Can you make a video just on op amps? I've done video about the noise, I think, for op amps some time ago, but not like specifically about op amps. I don't know if there is something super special to talk about op amps. Okay, how long we should keep going on? It's already 1 hour. Are there some last questions what I should answer? Video with guest about winding custom inductors transformers. I think that's like, I'm not exactly sure how. Always when I make videos, or very often, not always, very often I have to think about thumbnail and title and how many people may be interested in the topic. For example, when I make the AI videos, I do them because I'm really interested in the topic, but looks like no one else is interested in the topic. So about winding custom inductors transformers, it's hard to say how many people could be interested. And again, I don't know anyone. And I have talked to many people and no one ever mentioned winding custom inductor and transformers. But maybe in future when someone will mention this, I will have a look into this topic. So being good at embedded software, a good skill for hardware design engineer, like being able to debug right low level, definitely. I think if you would like to be a really good hardware design engineer, then you should understand also some software, especially for more complex boards like Linux or operating system running boards. You need to know about software because if you just do the hardware design by yourself, then it may not be possible to actually maybe write drivers and run everything what you really would like to run on the board. How often will I stream here? I don't know. This was just suggested from people in my company, like we should do this because we would like to bring more people on our Discord. But if people like this kind of live streaming, I can do it more often. There are not so many people, so I don't have to embarrass myself in between or in front of thousands of people. But interesting that Robert is refusing to defend his Veritasium video. Do you mean the video with Eric Bogatin, where we talk about the Verisatium video? But there is I think there is nothing like what I should defend. I was just like, stepping aside and watching other people talking about the topic. Other people who know more than myself. Hi Robert, would you help me with a schematic and PCB design one ESP32 module. Uh, I don't really do that. It's not because I don't want to. Problem is I don't have time. I don't have time even for my own projects. I have to. Right now, I'm running, I think, like 3 projects in parallel for 3 different videos, and I don't really have time to work on others people projects. So yeah, it's very difficult with my time. Please make the video on assembly language hardware description. I think I don't know how many people would be interested in assembly language. It says Discord link is invalid. Which one? Which one? Where did you find it? Tell me. Because I think I created the... I tested the link. The one which is in the description under this video. And it should be non-expiring link. But maybe somewhere is a link which I posted a long time ago and it's expiring. Okay. YouTube. I think I tested this link. I don't know why. I will have a look into this. Okay. I think we should finish for today. So I would like to thank you very much, everyone who joined this live session. I hope I was not talking too much nonsense. I will not be able to rewatch this live streaming on YouTube. Usually I have to watch my videos maybe 3 times, you know, when I'm editing them, but I don't know if I'm going to watch this live stream. Okay, I should do this again. We will see. Let's see. Q Drives confirms the link shows the invitation to join, so it should work. Then I don't understand why for some people maybe it doesn't work and for some people it works. I don't know. Because I tested it and it looks like it should work. Okay, here is another question. RS485, for example, do you follow 120 ohm differential routing or due to low frequency? Oh, it's been a while. I was doing RS485. I don't remember how I did this. I think I placed the transceiver very close to the connector. I don't remember. I'm avoiding the interesting conversation. I can't answer on questions I don't know answers, and maybe some of them I missed. I don't know because I'm looking at the YouTube and I'm looking on this. But yeah, if I don't know answer, then I would not pick up the question. Okay, so let's finish it for today. And if you are interested, leave comments. Let me know if you would like to see it again. And don't forget to join our Discord because I'm there every day. Often I try to post something what I'm working on, so maybe you will learn a little bit more what I'm actually doing every day. So thank you very much for watching, and then see you next time. Bye. Don't forget to watch my other videos, especially today's one about CAN. Thank you. Thank you very much for coming. And, so I was not here alone. Bye.